Hi folks, so I'm back at the AU719. I have replaced all the filter capacitors, got them mounted. I'll talk briefly about that. Went through the regulator board. Remember, we found a defective transistor, the error amp in the regulated supply for the negative 32 volts. I've got everything put back together. The hum is completely gone. I'll show you on the scope of the distortion analyzer, and I'll show you some of the tips and tricks I've had to learn having done a lot of these AU7 series. I've done probably 6 or 7 AU717s, and this is probably my 3rd or 4th 719. And there's a few things you can do to make your life a little easier. Having said that, it is my opinion that the regulator board is probably the worst part of this job, so I tend to do it first, and then everything else is a lot easier after that. So come on in, we'll take a look, and I'll show you what I've already done. Okay, so in order to work on a regulator board, we have to take these screws off of here and take the bracket off of the board. Now with the filter caps in place, that's a bit of a bear. So I generally, if I'm going to do an entire rebuild, I will take these out first, and the easiest way to get those out, I find, is just cut these. There's enough wire, you can strip fresh wire, put them on the new capacitors, and I'll talk briefly about mounting those. But once these are out of the way, it makes getting this board out a whole lot easier, because remember, we have to get to these screws, which are easy enough, but then these, which are almost impossible because there's not enough wire to pull it up to get to those. With these out of the way, makes your life a whole lot easier. Okay, so I did a lot of work on this board. I'll put the schematic up, we'll talk about that, but I want to show you the underneath here. Okay, let me drop the camera a little so you can see what I'm talking about. But the new caps, even though they were probably this much longer than the old ones, fit just fine. There was plenty of room down here. The bottom is going to be about right here, and even if these touch the bottom, they're ground. It's not going to hurt anything at all. I bent these in. I can bend them in a little more if that's a problem. But once they're mounted and rewired, everything worked fine. I'll give you a hint. When you go to mount the new capacitors, I take the brackets off the old ones, I mount them onto the new capacitors, but I don't tighten them all the way. I just make them snug, but still I'm able to move the cap, and then I'll screw them onto the chassis, and then I can twist them as necessary to get the orientation right and get them as far away from the top or bottom as I need to. And I'll take the screws back out, snug those down all the way, then put the screws back in. It's a little tedious, but I have a long bit for my cordless screwdriver, so I can get those in and out fairly quickly. So that's the easiest way to deal with that. The board has a new relay, new electrolytic capacitors, a lot of new small signal transistors. I haven't straightened up or loomed and neatened up any of this wire yet, but I will do that before I button this thing up. Meantime, I want to show you how this works now. Now, if you remember, the problem we were having was we had 120 hertz ripple. So I am going to zoom in on this so you get a good look here. I'm going to turn this on. When it clicks out of protection, notice that these are perfectly flat. We have no kinks, no bends. That's perfectly flat. We have signal when I turn the volume up, and I can get about 100 watts of channel out of this 90 watt amp. Distortion's a little higher than spec, but not bad, 0.04% at 96 to 99. There's always a little bit of imbalance in these due to wear and volume control, component aging, component tolerance, but this thing puts out quite a bit now. So I just wanted to talk briefly about that. The next thing I'm probably going to do will be the power supply modules. We're going to get those black flag capacitors out of here. It'd be a shame to blow this thing up now that we've done all this work. So we're going to take those out. And these are pretty easy because they're modular. They come out, we can work on them on the bench. I'll show you all the things we're going to do. We're going to replace the trimmer capacitors for the offset and the bias. Going to replace those black flags with a couple of C0G and P0. multi-layer ceramic capacitors. We're going to re-grease all the transistors, put new micas in, replace all the electrolytics, replace any small signal transistors that have a history of being bad actors. So that's going to be our next step. Okay, the next thing I'm going to work on is the output modules. That's these two guys here. The regulator board has been done, filter caps have been done. This is what I consider to be the worst part of the job. So I got those out of the way first. Now I'm going to go to the easiest part. These output modules are, as the name implies, modular, and it makes them very easy to work on. So I'm going to show you how we get those out and how we get them ready to be worked on. The other things we will be doing will be the equalizer board, and I usually take the jack board off the back and we just swing out the whole ribbon connector. And we have to pull this shaft out, which is easy enough to do. It simply pulls out if we take two screws off the front here. And then the last thing we're going to be doing is the tone control, and that's right down here, and we'll pull that out so we can get to everything and clean the controls really well. These will come out with it, kind of flops on the benches in assembly. So let me show you what we do to get the output modules out. Alright, this is simply a matter of taking some connectors loose. If you remember, we had to take these loose when we were working on the regulator. And these just pull out, and we will have to take a screw out of here so we can get this ground lead off. That's easy enough. All we have to do is take this screw out and the entire assembly comes up. Okay, just want to make sure I don't lose the screw, so it goes in the bag with the screws to the output module like so. Okay. And now, that's all the wiring we have to remove to get the module out. The only other thing we're going to have to do is there are screws down here and here that have to be removed. So I'm going to pull those out. Okay, so with the screws removed around the perimeter, the module should simply pull out. Now I have the ribbon connector. I just had to push a little out of the way, and our ground was kind of hooking up, but now we have the module out, and all we have to really do is remove these 5 screws here, and this entire PCB can be leaned forward and allow us to access the back of it so we can change our parts out. Okay, so I took those 5 screws out, and I've shown everybody this bag system before, but I guess it's worth repeating. All parts go into these little Ziploc bags. This is the output board mounting, and inside are the screws from the PCB. So now this lifts up, and they all go into what I refer to as the master bag. All the parts go in here. They're labeled as to where they go, what they are, and this helps me to keep things together. If I have screws left over after assembly, that means I forgot to put some screws back. So that's the approach I take with those. Anyhow, like I said, now that we have this free, we can gain access to the back, and it makes it very easy to get to all the parts. So we are going to replace electrolytics. We are going to replace the dreaded black flag capacitors that we see here. There's one on each output module. We're going to replace the trimmers, and we are going to replace all the micas on both the output transistors and the driver transistor to put fresh heatsink compound on them. We'll see if there's any bad actors as far as small signal transistors go. I don't believe there are on this module, but I'll take a look at what we actually have as opposed to trusting the schematic, because you never know what you actually have. It can deviate from the schematic depending on any revisions that were made after the schematic was drawn. Okay, I have both modules out of the amplifier and here side by side on the bench, and this one I've already done. I've gone through here and I have replaced both of these decoupling capacitors, and I'll talk briefly about that in a bit. All the rest of the electrolytics that are populated on this board, That's where the black flag was, where we had the NP0 multi-layer ceramic capacitor installed. And I've replaced both trimmer pots for the bias and offset, and I have replaced the micas on these transistors and put fresh heatsink compound in them. And underneath the board we have the output transistors, which also got new micas and new heatsink compound, which Sansui puts on here underneath this standoff here and up on top, which goes to the heatsink assembly that these guys are mounted on. So it just keeps the thermal coupling to be as optimal as possible. So we got to do the same thing on this. Now I took the black flag capacitor out of here, and I'm going to show you a picture of what it looks like when I tested it. Now this is supposed to be 22 picofarads. You can see it's about 10% of that. So this capacitor was definitely bad, and that's a very bad thing because it allowed the amplifier to self-oscillate, potentially destroying the output transistors. And here's a picture of the replacement, the multi-layer ceramic that I put in, which is much, much better. You can see it reads out at the correct value. One of the other things you can do, it's not a big deal, but these terminals get a lot of tarnish on them, and I'm not sure how well you're going to be able to see this. I may have to post a picture, but you can buff these up with a piece of eraser. I had one of these eraser sticks that have a long eraser. I just cut a piece off and got a hole poked in the end here. You can just put it on and turn it by hand. You could put it into a drill, but if you just turn it by hand, it buffs them up and takes the tarnish off really easily. Again, I'm not sure this is a big deal. I've read where people do this, but the eraser does a really good job. You can see how much shinier these two are as opposed to this one. So that's something else that we can do. Now, I said in the past that it's always a good idea to do one piece and then test the amplifier. And while it appears I'm breaking that rule by doing both of these modules, the modules completely unplug, allowing them to be isolated. So if there's a problem when I install it and try to test it out, I can unplug one or the other and isolate the trouble to whichever one that it is. There's not a lot replaced on these that would cause it to have problems. I'm very careful to note the polarity of all the electrolytics I put in, and I also replaced some of the Zehners that are in the circuit. But we'll take a look at this. When I get this finished up, we'll install it and we'll test the device again. And while I've got them out, I want you to see the filter caps. There's a lot of space in here, so that's why we didn't have any problem replacing these much longer ones. We had space up at the top. We had quite a bit of space down here at the bottom, because remember, the bottom is going to be about right here. So normally that may have been a problem, but in some amplifiers you have quite a bit of leeway, and this is one of them. Okay, so I've got the modules mounted back into the amplifier, and now we can fire it up, and I just want to take a quick look at the bias and offset, because remember, we changed the pots out, and I did rough them in, but these are our bias test points right here, and they simply go across the emitter resistors, sorry, here and here. See, we have a test point here and a test point here, so it just goes across the two emitter resistors. So not only can we test our DC bias here, we also can test our offset, because remember, offset is going to be taken off the output, which is the junction of those two resistors, and ground. So we can just go from either one of these test points to ground to get a rough idea of what our DC offset is. Now, I'm just going to set these real quick. The amplifier is supposed to be on for like, I don't know, 4 or 5 minutes to warm up and stabilize before you have your final setting. I'm not going to bother doing that until this thing is completely rebuilt. Then we'll go through all the adjustments and we'll do it by the book. Meantime, we're just going to rough it in. Just set our DC bias to 20 millivolts and our offset just so it doesn't trip the protection circuit. So anyway, I'm going to turn the amplifier on. And we show no bias at all. Okay, so our bias is here. There we go, starting to climb. And we're just going to leave it right around there. Okay, so to test our offset, we just go to ground. Our offset's pretty good. I'm not going to mess with that because they're pretty touchy adjustments. Okay, other channel, same thing. They did polarize the test points. So we're going to go like this and like this. Oh my God. There, finally. Okay, we've got about 8 millivolts of bias. And we're going to leave that right about there. Same thing. We just take this off and go to ground. Again, that's nothing to worry about, and you'll see how touchy it is. Okay, I'm going to leave that right there. That's probably as good as that is ever going to get. So now we have adjusted our bias and offset. Again, these are just roughed in, but we have a good idea where we are. So I'm going to take the meter out of here, and we are going to look at the scope and put some signal in here. And see what we can get. We're just starting to clip, back it down. And that looks pretty good. We've got 92.4, 93. The output levels are a little bit closer than they were before, and I didn't really expect that. We have about a 0.02 and a 0.04% distortion. We'll have to see how good that is. It may get better as we go along because remember, we are going through the entire amplifier. This has no pre-main jacks on it. So we'll see if that gets any better. We'll see what it might take if it doesn't meet spec. I don't recall what the spec was. Now, I did say I wanted to talk briefly about the decoupling capacitors. And that would be, let's see, on here. They're 470 microfarads, but this is the schematic of the other channel that doesn't show the values. And I'm trying to see where they put them here. I believe they're here and here. Now, they were originally 470 microfarad, and I put in 820. Now, why did I do this? A, I had them, and B, there's a gentleman who goes by Lee Stereo on a popular audio forum that he and I are both members of, and he routinely does this. And he says that he gets a lot better sonic results. You can find his thread, why does Lee Stereo always increase decoupling capacitors? And you may get a better idea of why he does it. I followed it, never caused any problems, always gotten good results, so I have continued to do that. They fit, haven't caused any problems. I think they improve things, and that's why it was done. So we're going to move on, and the next thing we're going to do is going to be the equalizer board. This is the Phono EQ board. So we're going to take it. In order to get it out, as I said, you have to take these two screws out of the front. Can you even see where I'm pointing? I think so. And then this shaft will just pull right out of the coupler. And also, I want to show you this. We are going to pull the jack board off the back. I want you to get a good look at this because, wow, These are extremely tarnished. They are almost a black color. So I'm going to see if we can clean these up. Now there's a fine point between cleaning them up and taking the plating off of them, and I don't know if the plating is gone, but in any event, this board gets pulled out along with the EQ board, and the ribbon connector and the board all come out. So that's going to be our next step, and then I will talk about the items that we're going to replace on there. Okay, so I have the equalizer board out now. In order to take it completely out, you need to remove the tape loop selector board, and then you can take everything out. This is the RCA jack board. I got the first 4 of these clean. They look pretty good. It takes a lot of work to get them that way. Fortunately, the plating's still okay. I don't know why they got so tarnished. But we're going to clean these selector switches while we have this open. The other 2 black flags are here and here. They're going to go. All the electrolytics are going to go. I don't think there are any small signal transistors that need to be replaced. I need to look and see if there are any coupling capacitors that need to be changed or upgraded to polypropylene, which is a slightly better dielectric. I may change these pots out depending on whether or not I have the right orientation and value for those. It's going to be quite a bit of work to get this done, so I'm probably not going to get this video published today. We'll see how it goes. Okay, so I've got the EQ board recapped, and that's all I did was a straight recap. None of the semiconductors except for the Zener diodes were replaced. I've got it reinstalled. Everything appears to be working. It's very important that when you reinstall the board that you check all the functions, Phono 1, Phono 2, tuner, and aux, because these ribbon connectors can be easily broken, and you may find that after you reinstall everything, you may be missing a function, or function will only work on one channel. This happened to be before on the 717. The jacks cleaned up really nicely. I don't know if you can see how shiny these are now, but they were grayish, almost black, and now they look great. I've got it currently set on Phono 2, so that's what we're going to test. And just to give you an idea how hard these things were to clean, those are all the foam bits I used to clean these out. You can see how nasty they were, and it took about 3 or 4 different applications to get it truly buffed up like that. So this has all been reinstalled. I've got the I tested on the dim bulb, and now we're just going to run some signal in, see how it looks. Now when you're testing the phono input, you need to drop the amplitude out of the generator, so I'm feeding in 25 millivolts. And you can see we got plenty of output. That clipping is the analyzer not auto ranging fast enough, and that's actual clipping of the amplifier. So we drop it down a little bit, and we are 83 and 91 watts. 0.03, 0.04% distortion out of the phono. So that's looking pretty good. The last frontier here is we have to go down in here and we have to pull the tone board, replace all the caps on that, clean all the switches, and that'll be it for this thing. It'll be totally gone through, and one of these days I really got to start selling all this stuff because I am like up to my chin in refurbished stereos I never do anything with. Alright, so the equalizer board is completed, and the last board in here was our tone or control board down here. Now, I did quite a bit of work to this, replaced all the capacitors. There were some known bad actors in here as far as transistors went. There were also some on the EQ board I had forgot about. I had to go back and replace. I replaced some of the capacitors with films. I have some polyester here, and there's a guy who goes by Lee Stereo on a popular audio forum, which I'm a member of. You can find him with a Google search. And he has some very, very interesting upgrades that he goes through. And he's very knowledgeable, and he will tell you why he did a particular upgrade. So I followed some of his instructions for this. Some of this I left bone stock, but on the tone control board I did change out to some film capacitors here. This is pretty much a direct coupled amp. It has no coupling capacitors to speak of, and due to its high frequency response, I can see why. But anyway, if you want to know if your tone board is working, sine waves won't tell you. You need to use square waves. So what I've done is I've fed square waves into this amplifier from my HP 8904A over there. And if we turn the volume up, you can see that's pretty square. I'm going to speed up the sweep here so you can see just a couple cycles of square wave. And the way square wave testing works is you will see anomalies you won't see with sine waves. If you have very good high frequency response, you'll have a very sharp rise here. If you have very good low frequency response, you're going to have a flat top across here, because that's what you need for essentially DC, is a good flat top. Fast rise tells you have good high frequency response. So when I turn tone controls on, you can see if I turn the bass up, what have I got going here? Okay, you see that's the treble, and it over accentuates or exaggerates the fast rise. And if we go to the bass, you can see there I have it all the way off. We have a pretty serious slope there. If I turn it up, it straightens out. If I turn the treble down, that looks more like a square wave. We can change the range. And that's our bass. That's more bass, less bass, more treble, less treble. So you can see if your tone controls are actually affecting things the way they should be. And I'm clicking in the different ranges, the different turnover points. But anyhow, our tone controls look like they're doing their job. And again, a sine wave is not going to tell you that. We'll just put the sine wave back. And this is a 1 kilohertz sine wave. My generator puts out all different frequencies, but 1 kilohertz is where most distortion is tested at. And your tone controls don't tell you a lot. That's why you need to use a square wave to make sure that your tone controls are working. Our tone control board is completed. Now the last thing we're going to do is I'm going to leave this on for a while. We're going to set the bias, offset, and there is also an offset on the EQ board for the phono input, so we're going to set those as well. Okay, so we're going to adjust the bias and offset. Now, the 717 and 719 have test points right up at the top of the board, and we're connected to those. Those are connected to my 2 benchtop meters. It's nice having 2 meters. It's also easy to get confused with what pot you're turning and which meter you're looking at. Also, since you have a bias and offset, you may need to make sure you're not screwing those up as well. Take it from me, I've done all of the above. Now, our instructions say to run the unit for more than 3 minutes before making these adjustments. And it says to do the offset first. It really doesn't matter. We'll check both. The offsets are easily set because it says to test them at the speaker terminal. Since I use dual bananas, they plug right into the front of the benchtop meters. So we'll take a look at that. Meantime, we can turn off the noisy test equipment. We're going to set our bias to 23 volts. So if you look here, and I'm going to zoom in a little bit, we have 19 and 21 millivolts respectively. So I'm going to tweak these so we get around 23. Okay, so this is the top meter here. Okay, doesn't take a lot. Helps turn them right way. So it's 23 plus or minus 1 millivolt. That's about 22. Other one. Now these are going to drift a little with temperature. I'd like to set them a little bit low. I'm going to set them. Okay, so those are both within 1 millivolt. And now to check the offset, you can rough them in by just taking one of the leads off of the test points here and just connecting it to the chassis. Ideally, you want to check them right at the speaker terminals. Now the other problem I always have is I can never figure out which is the front, back, left, or right. So we're going to disconnect our test points here. Okay, 4 leads out. And now we just connect our speakers right to the front. Those are coming from the speaker outs. So I'm going to put the meter back on. For this, they want 0, give or take 5 millivolts. I can tell you, these are not fun to adjust. They're very, very touchy. Okay, this one in the back is the left. I'll leave that there. One in the front is the right. And I am barely breathing on these, folks. This is a really touchy. These are really touchy. A lot of people will spend extra and have multi-turn pot, get multi-turn pots in. They're a little pricey, and you can get it if you're patient. As a problem, I'm not the most patient person you've ever met. But take your time, and you can usually get them pretty well. This is actually going down into the microvolts. Now the whole point is you want these balanced. If you've ever plugged in a speaker and heard a pop, or if it pops when it comes out of protection, that's usually from offset. So those are looking pretty good. Let's see. The only other thing that needs to be done to this is I need to paint the front panel, which I seem to have misplaced back here. I wanted to show it to you. Give me a moment. I want to show you the front panel. The cover. Okay, so in order to get the offset on the equalizer board, I find it's easier to use the test points on the back. They're almost impossible to get to from the front of the circuit board. So I clip on, thankfully they're marked here and here. And again, I have 2 meters. And you need a really small adjustment tool to get this adjusted. So if we look here, and I'm going to try and get my hand out of there so the camera doesn't keep auto-focusing on it. Let's zoom in. And I'm adjusting the top one first. We want 0, give or take, 50 millivolts. So we're at 390 millivolts now. Okay, so it's a real touchy adjustment. And it's one of those that you get close and you should just leave well enough alone. Okay, I'm going to power this off, scrub these pots a little bit, maybe drop some contact cleaner in them, and then we're going to come back. Okay, so I've worked for this a while, and I've got it around 3 millivolts, but it moves around a lot, and the other channel I've got down around 20. It says give or take 50. and considering how touchy these adjustments are, that should be well within spec. Okay, so the cover has some rust in here. If you look, you can see we have rust along here, got a couple of rust spots here, here, and here. Now, painting is not my forte, but I have learned a few things over the years. Painting is a lot like many types of Asian cooking where it's all in the prep. There have been Asian dishes I've tried my hand at, and you're chopping and cutting vegetables for what seems like hours, and then you stir fry it for 2 minutes. So too with painting, it's all in the prep work. You've got to get rid of every bit of this rust. Rust is like cancer. If there's even a little left, it'll bubble up under your paint. But if you get down to bare metal, you get all of it away. Depending on the paint you use, you may have to apply primer before you paint it. There are some great paints out there. I did a Sansui AU717 that had horrible rust. This is a picture of it here. And I used a Rust-Oleum hammered finish. It says black, but it actually looks more gray. And you can see what a great job it did. And it was a very good match. It works for the inside of the cover and the outside. I'm going to have to try a satin black on this. I may just do a short just to show you how it comes out. But anyhow, this finally concludes this guy. I'm going to reassemble everything. I'm going to take the front panel in the house and wash it really well. Get all the dirt and stuff off of here. Wash all the knobs. Put that all back together. And I think I am going to make a short just to show you how the rest of it comes out. So anyhow, folks, that's all we got to do with this one. It's been totally gone through. And I will post one photograph of all the parts I took out right before I conclude this video. But as always, I thank everyone for watching, and I like giving back to the community that's given me so much. Thanks a lot, folks.